So how do we find the minimum or the maximum value of a quadratic function using the completing of squares? In our previous lesson, we said that the quadratic function is of the form where a is not equal to 0. The standard form of this quadratic function is also given as so this is the standard form of the quadratic function, and we can obtain the minimum or the maximum value from this standard form. The key here is the minimum or the maximum value. And this minimum or maximum value occurs at x minus h. So how do we obtain this standard form of the quadratic function? We can do that by way of what? Completing the squares from the quadratic function. So let's do just that. So in completing the squares, the first thing that we are supposed to do is to make sure that the coefficient of x squared is 1. And we can do that by factorizing a out. So we'll be left with what? S squared, then we have plus bx all over hot a, and then plus c all over hot a. Now once the coefficient of x squared is 1, then we move on to the coefficient of what? X. So what we are going to do to the coefficient of x is that we are going to multiply the coefficient of x by half, and then we square it. We are going to multiply the coefficient of what? X, which is b all over a. We multiply it by half, and then what do? We square it. So the product of this is going to give us b all over what? 2a all squared. So what we are going to do is that we are going to add and subtract this to the expression. So we are going to add this, and then we are going to subtract this. We are going to add this to the expression here, and you agree with me that when we sum this together, it is going to give us 0. So it means we have done nothing to the expression. Plus b all over 2a all squared. Then we have minus b all over 2a all squared plus c all over a. Now once we have this, let's group this s squared and then this together. So we are going to have s squared plus b all over 2a all squared. Then we have minus b all over 2a all squared plus c all over what? A. Now with this, we can write it as x plus b all over 2a all squared. And then we are going to have minus b raised to the power 2 all over 4a squared plus c all over what? A. So when you simplify this, you are going to get minus b squared minus 4ac all over what? 4a squared. Now once you have this, let's multiply through by what? A. So we are going to have ax plus b all over 2 all squared minus b squared minus 4ac all over 4a squared. We are going to multiply 2 by what? A. So this will multiply this will multiply that. So this a will cancel one of what? The a. So we'll be left with then we have b squared minus 4ac all over 4a. Now once we have this, we are going to let the variable h be equal to minus b all over 2a, and then k be equal to minus b squared minus 4ac all over 4a. So we are going to substitute this h and k in place of the whole of this. So we are going to have ax minus h all squared plus what? K. So this is the standard form of the quadratic function. So from this, our k is what? Our minimum or maximum value. And this minimum or maximum value occurs at x minus h is equal to 0. So we are going to base on this completing of squares to find the minimum or maximum value of a quadratic function. So let's take our first example. So we want to find the minimum of the quadratic function and the value of x where it occurs using the completing of squares. So it means that at the end, we should get something of this form. So let's complete the squares of this very function. So we have So in completing the squares, the first thing that we are going to do is to make sure that the coefficient of x squared is 1. So from this, we can see that the coefficient of x squared is 1. So we are not going to do anything to it. Then we move on to the coefficient of what? X, which is what? 2. So we are going to multiply the coefficient of x by half, and then we square it. So this is going to give us 1 all squared. So we are going to add and then subtract 1 to the expression. So we are going to have x squared plus 2x plus 1 squared minus 1 squared minus what? 3. So let's group this x squared and then this 1 squared together. So we are going to have x squared plus 1 squared, then we have minus 1 squared minus what? 3. Now we can write this as x plus 1 all squared, and then we have minus 1 minus what? 3. So we are going to have x plus 1 all squared minus 4. So from this, we can see that this is in the form of this. So this number here, which is 4, becomes our minimum value. And this minimum value occurs at x plus 1 is equal to 0. So you can see that our x is equal to minus 1. So the minimum value of this quadratic function is minus 4, and it occurs at x is equal to minus 1. Let's look at one more example. So we have our second example. We want to find the minimum of the quadratic function and the value of x where it occurs using the completing of squares. So it means that at the end, our final answer should be in this very form. So we have our function So in completing the squares, the first thing that we are supposed to do is to make sure that the coefficient of x squared is 1. So looking at this, the coefficient of x squared is not 1. So to make it 1, we have to factorize 3 out. So when you factor 3 out, we'll be left with what? X squared minus 2 all over 3x plus what? 1 all over what? 3. So after making the coefficient of x squared to be 1, then we move on to the coefficient of x. So with that, we are going to multiply the coefficient of x, which is minus 2 all over 3, by half, and then what do? We square it. So this is going to give us minus 2 all over 6 all squared. So we are going to get minus 1 all over 3 all squared. So we are going to add and subtract this to the expression. And you agree with me that when we sum these together, we are going to get 0. So we have done nothing to the expression when we substitute this into the expression here. So we have x squared minus 2 all over 3x, then plus minus 1 over 3 all squared minus 1 all over 3 squared, and then plus what? 1 over 3. Now let's group this x squared and then this squared together. So we have x squared plus minus 1 all over 3 squared. Then we have minus 1 all over 3 squared plus 1 all over 3. Now with this, we can write it as x minus 1 over 3 all squared. And then this, when we expand, we are going to get 1 all over 9 plus what? 1 all over 3. Now when you simplify this, you are going to get plus 2 all over what? 9. Now let's multiply through by what? 3. So we are going to get 3x minus 1 all over 3 all squared plus 2 all over 9 times what? 3. So from here we can see that this 3 will cancel 9. We have what? 3. So at the end we have 3x minus 1 all over 3 all squared plus what? 2 all over 3. So from this you can observe that we have expressed this quadratic function in this very form. So here this becomes what? Our minimum value. And it occurs at x minus 1 all over 3 is equal to 0. So we can see that our x is equal to 1 all over 3. As easy as that. This brings us to the end of today's lesson. See you tomorrow. Bye bye.